Welcome guys again to the H2O Spirit channel. Today we are going to be doing physics, as you can see on the board. This is physics by the H2O. Sorry we couldn't paste our videos last week. We were having some technical errors and issues, but we promise to serve you better this time. Okay. Our topic today will be area expansivity of material. If you have not watched our previous videos on linear expansivity, please, you have to do that. It is important so that you can understand this better. So I want you to join me as we go area expansivity. It is called gogodization. Okay, so area expansivity means this is the increase in area per unit area per degree rise in temperature. From the definition, you can coin the formula for area expansivity. First of all, the symbol for area expansivity is beta, as you can see on the board. It's a B-like symbol. Okay, now let's go to the formula. Area expansivity, which is also called superficial expansivity. You either call it area expansivity or you call it superficial expansivity. Area or superficial expansivity is the increase in area, which is change in area, per unit area, which is the original area, per degree rise in temperature. This rise in temperature means change in temperature. And please do not forget that area expansivity is equals to 2 times your linear expansivity. This symbol here means linear expansivity. So area is 2 times linear expansivity. Remember, we're going to look at the meaning of these symbols that you are seeing on the board. Firstly, we are going to look at this symbol. This symbol simply means change or increase in area. Please take note of this. In change or increase in area. Change in area is either theta A2 minus A1 or A1 minus A2. When you have A2 minus A1, it means there is a rise in the area, so that the final area is greater than the initial area. That's what you are seeing here. But when you have A1 minus A2, it means that there is a decrease in the area of the object. There are some objects, when they are heated, they will constrict instead of them to expand. Some, when they are heated, they will expand. Now, in this place, you are seeing that A2 minus A1, meaning that when they heated the material, there was an expansion. Sometimes when there is a fall in temperature, the material will shrink, okay? This means that our original area will be bigger than our final area. That's why we have A1 minus A2. So be careful and be attentive to details. Okay? Now, this symbol A1 means original or initial area. Then we have delta theta, which means change or increase in temperature. Increase in temperature. Your increase in temperature is theta 2 minus theta 1 or theta 1 minus theta 2. So as it is for area, that's how it is for temperature. So there's either a rise in temperature or a fall in temperature. So take note of these important variables and their meanings, and then we are going to take a question on area expansivity so that you can see how this formula is applied in solving problems. Okay, so we are going to take an example. Let's take the first example number 1. Okay, we are going to take an example so you can know how the formulas are applied in solving problems. The question says that the question came out from JAM, which is UME, University Matriculation Examination 1996, question number 18. It means that if you study your expansivity very well, you are going to see the questions in your exam. So it is important. That is why this video is important for you. A thin square sheet of metal of size 0.20 meter. This is the length of one side of the square. This is the length. So L1 is equals to 0.20 meter. Don't forget, in area expansivity, what we need is not the length. What we need is the area. And don't forget that the area of a square is L squared, so that our A1, which is the original area, will be equals to L1 squared. So you must get that. And that will give us 0.20 squared. By the time you square this, you are going to get 0.04 meter squared. So this is our A1. Take note of that. Is heated from 15 degrees Celsius to 75 degrees Celsius. Now, this is the change in temperature. So let's get our change in temperature. From this question, there's a rise in temperature, and there's a rise in temperature. It means that you have to do what? Subtract the smaller one from the bigger one. So we have change in temperature equals to theta 2 minus theta 1. Our theta 2 is 75, theta 1 is 15. So you have 75 minus 15. And that will give us 60 degrees Celsius, okay? Now, if the linear expansivity of the metal is this, find the increase in area. We are looking for the change in the area, which is also called the increase in area. Like I told you, your area of superficial expansivity is 2 of your linear expansivity. The question is based on area, not linear. So we are going to get our area of superficial expansivity by doing 2 times linear. Okay, now our linear is 1.2 times 10 raised to the power of minus 5 per Kelvin. So we are going to get 2 times 1.2 times 10 raised to the power minus 5, and that will give us if you multiply 2 by 1.2, you are going to get 2.4 times 10 raised to the power minus 5 per Kelvin. So this is our area expansivity. Now we are told to calculate for the increase in the area, which is also called your change in area. So your change in area will be unknown. Remember, the formula for our area of superficial expansivity is the increase in area all over the original area times change in temperature. So this is what we have now. We are going to substitute our variables into the formula, and then we get our answer. Don't forget, we are looking for change in the area. So what's our linear expansivity? It is 2.4 times 10 raised to the power of minus 5 equals to change in our area over the original area is 0.04. So you have 0.04 times change in temperature. We have gotten that it is what? 60. So it's very cheap. You can get your increase in area by cross multiplying the value. So our increase in area will give us 2.4 times 10 raised to the power of minus 5 times 0.04 times 60. So if you multiply 2.4 by 0.04 multiplied by 60, you are going to get your change in area equals to this, multiply with this will give us 5.76 times 10 raised to the power of minus 5 per Kelvin. Meter squared. That's the unit for your change in area. So this is your change in area, 5.76 times 10 raised to the power of minus 5 meter squared. So if you watch very well, you will find that the answer is not D, the answer is not C, the answer is not A, but the answer is what? B. Please be very careful, because jam can take you off balance. If you watch very well, you see that their powers are the same, but be careful. What we have here is 5.76. okay, we are going to take another example in this video, so Now we are going to take another example. Let's look at this quickly. Still on area expansivity of materials. A thin aluminum plate has a surface area of 1.500 meters square. This time they did not give you length, they gave you area directly, so you don't have to square it. So what do we do? Very easy. A1 is equals to 1.500 meter square. You can even throw away this zero. You know, any zero that comes after decimal, they are not relevant. So let's do it this way to help ourselves. Okay, 1.5 meter square at 20 degrees Celsius. That's the initial temperature. So our theta 1 is 20 degrees Celsius. What will be its surface area when it is cooled to minus 20 degrees Celsius? So what will be the area, meaning we are looking for A2, that's what will it be when the theta 2 becomes minus 20 degrees Celsius? Please be very careful. Just like I told you, there could either be a rise in temperature or a fall in temperature. In this question, there is a fall in temperature. Look at it. From 20 degrees Celsius to minus 20 degrees Celsius. So what do we do? Will it still be theta 2 minus theta 1 or theta 1 minus theta 2? Please, it's going to be theta 1 minus theta 2 because this one is higher than this. So be careful. So what do we do? Our change in temperature will be theta 1 minus theta 2. That's how it's going to be. So what is our theta 1? 20 minus, this one is minus 20. Remember, minus minus will give us what? Plus. So 20 plus 20 will give us 40 degrees Celsius. Did you get? So be careful. Whenever you see that the initial temperature is higher than the final temperature, please do well to subtract the smaller one from the bigger one. And whatever you do in the temperature will also affect the area. So our area is going to be theta 1 minus, A1 minus A2. That's what our area is going to be. Now, we are told to calculate for the second area. But I think what we have to do in this question is to find our change in area first. Let's get our change in area. When you get your change in area, then you can calculate for your A2. So remember, our formula says that your superficial or area expansivity is change in area over the original area times change in temperature. This is our formula, okay? Now, what we need is this, and this. That's what we need to calculate for our change in area. Do we have A1 in the question? Yes, look at it. Do we have change in temperature in the question? Yes, look at our change in temperature. We are looking for, do we have our area or superficial expansivity? No. So what do we do? It means that we must get our area expansivity. And remember, I told you that your area expansivity is equals to 2 of your linear, so that you have 2 times, your linear is 2.5 times 10 raised to the power of minus 5. So remember, 2.5, 2 times 2.5 will give us 5.0 times 10 raised to the power of minus 5 per Kelvin. I've told you, whether you have per degree Celsius or per Kelvin, they are the same. So we have this, our area, which is 5.0 times 10 raised to the power of minus 5 is equals to change in area all over A1. What is our initial area? It is 1.5. Change in temperature is what? 40. So what do we do? Cross multiply. When you cross multiply, you have your change in area. You have your change in area equals to 5.0 times 10 raised to the power of minus 5 times 1.5 times 40. Okay? So we are going to use our calculator to get these values. If you multiply this by this, we are going to get these values. Okay? 5.0 times 1.5 5.0 times 10 raised to the power of minus 5 times 1.5 times 40 will give us 0.003 meter square. That's what we get. Is this value our answer? No. We were told to calculate for the second area. Remember, there is a fall in temperature. A fall in temperature will make the area to fall. So take note, the initial area will be bigger than the final area. So we have change in area is A1. Please, not A2. A1 is bigger because there's a fall in temperature. So we have A1 minus A2. What's our change in temperature? Area, we have gotten it. So 0.003 is equals to A1. This is our initial area. Okay, our initial area is 1.5. Okay, minus A2. So how do you get A2? Bring your A2 here so that you have A2 equals to 1.5 minus 0.003. Okay, let's quickly subtract 0.003 from 1.5 and see what you are going to get. Minus 0.003, 1.497. So 1.5 minus 0.003 will give us 1.497 meter square. Okay, so let's go to the option and check. We have the answer is not A, the answer is not B, the answer is not C, but the answer is D. Okay, finally we have come to the end of this video. If you want to get more of our teachings on the H2O Spirit channel, please subscribe to this channel so you can always get our videos whenever we come online. And please do not forget to turn on your notification bell so that you can always get notified, and you can do well to help us share our video. Thanks very much for watching this video. We'll see you in our next video.